Are we online? Oh, great. So we'll start with the handwritten digit recognition. So with the development in the field of artificial intelligence, there has been a huge emphasis over image recognition. To develop an artificial intelligence which is similar to a human brain, we need variety of algorithms to make it work like a similar to which has similar functionalities as a human brain, like recognition of an image, pattern recognition, speech recognition, and many more. So right now we'll be dealing with the image recognition part, the field of manipulating, recognizing, and learning an image is called computer vision. So computer vision deals with the process of reading an image and recognizing the content of it. So why is there a huge problem with the image recognition? As you can see in the image, the computer has been asked to recognize a coffee mug. The computer would recognize various other feature or other things in the image as also a mug, but a human eye can easily recognize the blue mug in front of us. So where does the machine go wrong? So the machine sees the image as a simple numbers at the pixel level. So at the pixel level, it's all about the numbers to emission. So we need to teach a machine to how to read these pixels and visualize the structure to recognize an object. So the proposed solutions for this problem would be from the machine learning. Machine learning is latest science. Machine learning is a field of algorithms where algorithms are developed to learn from the data set and test on the labeled data. So in our problem, we need to create a feature representation and then feed the learning algorithm to create a black box which takes an input and formulates the output. So there are two types of algorithms in the machine learning. Those are supervised learning and unsupervised learning. Supervised learning is where the learning algorithm is trained over the labeled data and later it is calibrated over the test data to increase its accuracy. Unsupervised learning uh, is a learning algorithm which runs over a real-time data. It is more of a self-learning which labels the data set on as it goes. So which could be more accurate or inaccurate over time, but supervised learning is like more teaching a kid to learn stuff. So right now we are dealing with a MNIST dataset. MNIST dataset is a subset of a NIST dataset. The NIST dataset is a uh, humongous database of images of numbers. So the MNIST is a small subset of that, which has the process output of those images, which are clean and normalized. So the 70,000 of these samples are selected. So each sample has a 28 by 28 pixels. So that computes to be 784 pixels of features for each image. The 70,000 samples are divided into 60 samples of training data and 60,000 samples of training data and 10,000 samples of test data. So for this problem in the machine learning, we'll be using the deep learning concepts to implement and provide a better solution for the problem. So deep learning is a machine learning model where we build a neural network which emphasizes on which is like a hierarchical network where one by one layer recognizes different features. So as you can see in this image, the input is a image of a girl. So the layer one just extracts the small features of a girl, like a wrinkle on the skin or a small non-linear differentiation in the image. Then the layer 2 recognizes the eye, nose, and the bigger features, which the layer 2 consolidates from the layer 1 and recognizes different feature. And layer 3 consolidates the data from layer 2 and consolidates into a whole face. So by the in the output, where it is classified into like or dislike, like this guy looks good, so there's a like output. So this is like a simple example for a Tinder. So the deep learning has various methods. Under machine learning, there's deep learning, and inside deep learning, there are various more methods. So in one of them is multi-layer perceptron. Multi-layer perceptron is where it's similar as I mean, the same as the deep learning concept, but just that each layer reads the data and just pass on to the different next layer. There isn't much consolidation in each layer, so we need more number of layers to. With this, there is not too much of validation, due to which this is very fast, but sometimes there is a probability of more error rate. But multi-layer perceptron works very efficiently for a linear perception, where the data is linear to be interpreted. So convolutional neural networks is another type of deep learning model, where this model has in the hidden layers, unlike multi-layer perceptron, it has a convolutional layer and a pooling layer, which improves its accuracy. So by more number of hidden layers being added, there is a multiple, I mean, exponential increase in the efficiency of the model. So this network works better on the non-linear images. So like layer m minus 1 has a huge number of nodes which are spawned to read data, and layer m consolidates those. Then a layer sent it to layer m1, m plus 1. So it becomes more and more efficient as you go up. So CNN, that is convolutional neural network, or UCI optical data set. This is an example of the output on UCI optical dataset, where we had used 10%, 20%, 30%, 40%, and 50% of the training set, and versus the different value of error rate. So as you can see, for the 10% training set, there is a 4% to 6% error rate change, with a range of 100 to 1000 nodes spanned. But as you keep increasing the training set, uh, the error rate drops to almost near to 1, which is very low. But as you can see, the nodes, as the nodes increase, even with the increase in the nodes, the accuracy also increases. So we had implemented the baseline multi-layer perceptron uh, with a one layer of input, then one layer of hidden layer, one hidden layer with obvious input and output layer. So that's just 3 layers. So which had a output accuracy of 98%, but execution time of 81 seconds. So then we had implemented a simple CNN where there was an input layer, a convolution layer, a pooling layer, and an output layer. So this was a basic CNN. So it has a 99% accuracy, but a huge execution time of 1000 seconds. And we had developed a complex CNN where we had used 2 layers of convolution layer and 2 layers of pooling layer. So which had increased the accuracy, but exponentially increased the accuracy execution time. So as you increase, then you can observe, as you can increase the layers in a CNN, you're reaching to higher accuracy, but losing on the execution time. So we had implemented these 3 algorithms using Python and the help of its libraries. So Theano is a visualization tool. It's an excellent framework where it uses the GPU to visualize the multi-dimensional array, whereas the images are 2D arrays. So it's very efficient to use Theano. And NumPy is used for mathematical operations like Fourier transform, linear algebra, and random function generator. And Keras is the heart of the Theano, which actually implements the neural networks and runs pretty fast. It's an open source tool. So in the conclusion, multi-layer perceptron is very accurate, almost closer to 2%, but very fast. Uh, but it's good. It's a good trade-off if you are using a huge data set. But coming to CNN, it takes a lot of it has a higher accuracy, but very slow in the process. So these are references. We conclude at the end. So thank you.